Everybody, today we're going to talk about two different types of angles that we're going to see inside of circles. And in order to talk about that, we're first going to talk about different types of arcs, because these angles are going to form different types of arcs. So remember that arcs are just pieces of the entire circle. We have three different arcs that we need to know, and the first one is a minor arc. And a minor arc is an arc that's less than 180 degrees. And here's two examples. We name these arcs by using the letters of their endpoints, so similar to a segment, and then we put this arc symbol on top, which is just kind of an arc. So arc LM is a minor arc. It's less than 180 degrees, and it's right there. Arc MN is also less than 180, so it's a minor arc. And it's this arc. It starts at M and ends at N. A major arc is bigger than 180, and we're going to use 3 points to name these types of arcs. So I'm going to get rid of the arcs that I just drew. So my arc in blue, arc MNL, starts at M and ends at L. So it starts at M and ends at L. And we know which direction it goes because of the point here, N. It tells us that start at M, go towards N, and end at L. So it's that arc that's much bigger than 180. It's actually almost the entire circle. So we can do the same thing with NLM. We'll start at N, we're going all the way to M, and we're going to go in the direction of L. So we're going around, and there's our major arc, NLM. And a semicircle is just half of the circle. A whole circle has 360 degrees. A semicircle has half of that, which is 180 degrees. So we have 2 semicircles in every circle, and we can name both of them NL or LN. And yes, I did make a spelling mistake. Make sure you don't make the same mistake. So a central angle is an angle that has its vertex at the center of the circle. So here, center C is the vertex of several angles inside this circle, and they're all central angles. And the thing that's nice is that a central angle has the same measure as the arc that it corresponds to. So in this picture here, I have this angle that's 58 degrees, and it creates this arc LM, and since this is a central angle, that arc that it corresponds to is the same size, and that's how we can show it. So let's find a bunch of different arcs in the same picture. We know that LM is 58 degrees. If we want to find the measure of arc MN, then we first need to know what its central angle is. This angle here and the angle that our arc corresponds with, they form a linear pair, so they should add up to 180. So that means that that angle is 122 degrees, which makes arc MN 122 degrees. The arc from L to N, we can see is a semicircle, so it is 180 degrees. The arc that starts from N and ends at M and goes in the direction of L, so arc NLM, that's a major arc, and we can find its measure by adding this semicircle of 180 to this arc LM, which is 58. We just add those two things together and we get 238 degrees. And we can do the same thing for MNL. We're starting at M, going towards N, and ending at L. So that's the combination of this 122 degree arc and this semicircle. So 122 plus 180, that's going to give us 302 degrees. If we added these two minor arcs and this semicircle, it should add up to the whole circle, which would be 360. So go ahead and pause here, and I want you to find the measure first of this angle and then the rest of the arcs. So if I'm looking for an angle instead of an arc, the process is the same if I have a central angle, because the central angle and its arc are equal. So angle MCN, this angle right here, is associated with this arc that's 57 degrees. So that means that angle is 57 degrees. Because we know that's 57, and these two angles form a linear pair, we know that this angle is 123 degrees, which makes arc NO 123 degrees. I apologize, I wrote 120. Arc LO and arc LM create a semicircle, so that means that their angles are going to create 180 degrees together. They're a linear pair. So these two add to 180, so that makes angle LCO 148 degrees, which makes arc LO 148 degrees. For NOL, we just add arc NO and arc OL, so 123 plus 148 gives us 271. And finally, MO is a semicircle, which is 180 degrees. So the other type of angle we're going to talk about is formed by two chords. So remember that we quickly talked about chords being segments that are inside of a circle with their endpoints on a circle. And the vertex of these angles lie on the circle. So M is a point that's on the circle. It's the vertex of angle LMN, and it is an inscribed angle. And the relationship that exists is that the angle that's inscribed within the circle, so angle LMN, its measure is half of the arc it corresponds to, so arc LN. So we can go ahead and find some values for angles and arcs if they're inscribed. If we look here at the angle that has the measure A, we're talking about an angle that has vertex here at L. It has this side LM and this side LN, and it corresponds to this arc. That's 120 degrees. So we have an inscribed angle. Its arc is 120 degrees. So we can take that relationship that the angle is half the measure of the arc, plug in the measure of the arc, and find out that A is 60 degrees. We can do a similar thing to get B. B is this angle right here. The vertex P, side PO, and side PM. And it creates, it corresponds to this arc MO. So that is a combination of MN and NO, which is 150 degrees total. So when we plug into our relationship, the arc measure is 150, B is half of that, so B is 75 degrees. So why don't you go ahead and find A and B here. So the arc B is that corresponding to this angle here that is 40 degrees. So if we plug into our formula, B goes over here for the measure of the arc. So it's a little different than the ones we just did. In order to solve for b, I can multiply both sides by 2, and that's going to cancel out this 1/2 over here, and I'm going to get that b is 80 degrees. The other way to do that is just to know that this arc is twice as big as the angle, so we can just multiply 40 by 2. To get A, you see that A is an angle that has a vertex L on the circle and sides LO and LN, and it corresponds to this arc of 70 degrees. So we can plug 70 into our formula. You get that the measure of A is 35 degrees. So if we have a tangent line and a chord that intersect at a point on the circle, so right here they're intersecting at this point, we have a special relationship that exists. So this is kind of a special case, and the relationship that exists is very similar to an inscribed angle. So we have an angle that's formed here, LNP, and it corresponds to this arc, and their measures are going to be related the same way as an inscribed angle and its arc. So the angle formed is equal to half of the arc. So in this example, we are looking specifically at this angle formed, SMN, and we call it x degrees. And it corresponds to this major arc, NLM. So the relationship tells us that this angle is equal to half of the arc. So we know that the angle is 106 degrees. You might notice too that this angle and this angle here form a linear pair. So since we know x is 106, we know that angle NMT is 74. And now, using the relationship we've established, this arc is 2 times as big as this angle. So this arc is 148 degrees. And we could also found this arc by subtracting a 212 degree arc from 360. So that's just kind of a side note. So pause and try this example. Find the measure of this arc labeled with x. So if we plug into the formula, now we're plugging in for the angle being 74 and the arc is x. We multiply both sides by 2 to cancel the 1/2, and we get that it's 148. So I want you to try this one you-do problem. There's 2 values you need to find. You need to find x and you need to find y. It's a little different than the problems we did. It's a combination of an inscribed and a central angle. Give it a shot and then check your answer in class.